Cloud Foundry provides a platform as a service, or PaaS, in which a developer can easily take a web application deployed on his or her laptop and deploy it to a hosted server that not only provides hardware, networking, and an operating system, but also provides a web server and the programming language, or runtime, and some web application frameworks. With all of this provided, the developer only needs to deploy the actual application code. Everything else is provided as a service on the server. Of course, this only works if the runtime and framework are built into Cloud Foundry, and popular things like Rails, Spring, and Sinatra are included. At present, Smalltalk is not included in the official release of Cloud Foundry. In this screencast, we explore one way of deploying a Smalltalk application into Cloud Foundry. Because Smalltalk is image-based, the distinction between application and in the framework is not typically visible from the file system, and some changes are needed to take advantage of Cloud Foundry's ability to copy a few small files and deploy them as a full application. For this exercise, we will use the Ada Web Framework, running on a Cog VM runtime. Following the instructions provided on this blog post, we create some directories, then download the Cog VM for our platform and unzip it to a shared location. Next, we download Ada, a 28 meg zip file, and unzip it. We can see that we have both on our local machine. Now we create a local working environment and copy an image and changes file from this shared location. We also set up a symbolic link to the sources file. We create a simple, self-contained file that represents our application. In our case, we modify a method in the web element class to identify the port being used by Ada Web. Because we will be running a headless server, we need to start the application from the command line rather than double-clicking on it through a GUI. We create a simple script, start, that pulls together the pieces, the runtime, the image, and our application. By adding the application file to the command line, we ensure that it is run when Smalltalk starts. Running the script starts the Cog VM, and we see the Ada image running in Pharo. The image we selected automatically starts a web server when it launches, so we can go to a web browser and see that Ada is serving pages on port 8888. Returning to Pharo, we can save and quit the image. Note that the save doesn't actually take place since we set the image to be read-only. We do see the changes file has been updated. When an application is deployed on Cloud Foundry, it is expected to listen on a port assigned to it as part of the startup process. The port number is selected at random from the ephemeral port range and provided to the application in an environment variable. Thus, we need to modify our startup to ensure that the environment variable is provided on the command line, and we will modify our Smalltalk startup code to switch to the designated port. We can test this change by setting the environment variable to a new port, launching Ada, and trying the old port. It doesn't work, then trying the new port. Next, we will modify the Cloud Foundry command line client tools to recognize Ada as a supported framework. To do this, we need to find the code that does the detection. This is contained in a Ruby gem, and we'll add Ada to the list of frameworks and edit the detection method so that if a file exists named ada.st, then we treat the directory as containing an Ada application. Our next task is to modify the Cloud Foundry server to support Smalltalk. We start by creating a tunnel between the client and the server so that web requests to vcap.me, which is mapped to localhost, will actually be served by our private cloud. Next, we open a shell on the server and look at the status. We see that vcap is stopped, so we start it. Once started, we can go to the client and get info, a list of runtimes, and a list of frameworks. Of course, Smalltalk, or the Cog VM, and Ada are not yet listed. There are a number of small edits that need to be made to Cloud Foundry in order to support Smalltalk. As you can see, we'll copy the code from our blog post that describes the steps. In most cases, the changes are pretty boilerplate and can be copied from the other runtimes and framework. I doubt that all of these changes are necessary. It looks like some are there to support upcoming features, but as we will see at the end, we do get it to work. One of the significant files is the chef recipe that installs CogVM and Ada Web. This adds support for the 32-bit applications to our 64-bit Linux system, then downloads CogVM and Ada Web, and unzips them into the opt Smalltalk directory on the server. Another significant file is the staging plugin, a Ruby script that helps create a droplet that can be deployed in various directories on various Cloud Foundry hosts to provide the application instances. Our approach is to copy the image, launch Smalltalk, file in the application, and then save the image, all as part of the staging. This way, the actual startup of each application instance does not have to do as much work. We still need to have the custom code to set the listening port on each startup, but this is relatively trivial, and the programmer does not need to be concerned with it. Once the changes are made, we can stop VCAP, do a new setup of Cloud Foundry on our virtual machine. Unfortunately, the setup script does not copy the staging files from our development directory to the deployment, so we have a few more files to copy. With those files installed, we can start VCAP, go to the client shell, and look at the server information, the runtimes, and frameworks. Note that Cog is a runtime and Ada is a framework. Now, from the client, we can update the application code, removing the code we added to change the listening port, and tell VMC to push our application to our private cloud. We give it a name and ask for 2 instances. The application is created. Staging takes a bit of time since it has to copy over 60 meg of files, launch Smalltalk, file in code changes, and save the image. We're told that the application failed to start, but I suspect that this is just a timing issue. We can look at a list of applications and see that we have 2 instances running. We can use a web browser to navigate to our deployed applications and see that one instance is listening on port 57142, and after refreshing, we can see that another instance is listening on another port, 34508. On the server, we can navigate to the location where VCAP places the running instances. We can look inside and see the startup script and the stop script. We can also see the files in the app directory. The staging.st file contains code used to create the image. It is run only once, and along with the ada.st file, could be deleted at the end of the staging process. Only one file, ada.st, came from the client and is used only during the staging process. The PID file identifies the OS process running Cog. If we look at all the CogVM processes, we see 2, one of which has a PID matching our PID file. The logs directory contains 2 empty files. Returning to the client, we can stop our instances, and when we look on the server, we see that the directories used for these instances are gone. We can then delete the application from the server and stop VCAP.